Well, welcome to an exciting topic tonight. We're going to talk about money. And of course, that all has to deal with interest. So our topic is called compound interest. We're going to start by writing out quite a few ideas here. So take your time, copy these down. And before I forget, grab that calculator. We are doing a ton of calculator work tonight. So first, what is interest? So let's underline that. Interest is the amount of money you receive for lending money or the fee you pay for borrowing money. Compound interest, let's underline that, is the interest that is calculated using both the principal and the interest that has accumulated in the past. The compounding period is the interval of time between the occasions when the interest is added to the account. Now, hopefully, principal is a word you're familiar with. Principal, and we'll denote that with a capital P, is the sum of money that you invested. So maybe you want to take $500 and put it in a bank account, or $800. That's your principal, the amount you're investing. The annual percentage rate, also known as APR as an abbreviation, we're going to use lowercase r in decimal form to identify the rate that we're going to get on our money, or the rate we're going to pay. And then here's how we talk about compound interest. If compound interest is paid twice a year, we call that semi-annually. Okay, so we do have to be familiar with these terms. Semi-annually would be twice a year. If compound interest is paid 4 times a year, we would call that quarterly, right? 4 quarters in a whole, 4 quarters in a dollar. So quarterly would be 4. How about if they told us compound interest was paid monthly? What number would jump in your head? Hopefully 12, and annually would be just 1. Notice semi-annually was twice, and then annually was just 1. So again, our goal is just to get some terms out there. Hopefully you're familiar with some of them. Maybe they're all new to you, and that's a good thing. But we'll keep going. All right, so our first topic we want to hit is called compound frequency. Now, here's the formula for it, so let's go ahead and box that in. And we do have to memorize this. Now, I think once we use it a bunch of times, it's not going to be a big deal. So it might seem overwhelming at first, but really, it won't be too bad. So f of t equals p times 1 plus r over n to the nt. So I just want to label some things here. My f of t is going to be my future amount. Okay, my p is my principal that we just talked about. 1 is the number 1. R is the R we just talked about, the rate. N is the number of times compounded. And we just talked about compounding annually, semi-annually, monthly, quarterly, etc. We're just going to use that N again, and T is obviously time. Okay, so again, once we use this, it won't be too big of a deal. So my future amount equals my principal, 1 plus the rate divided by the number of compounds, and the compounds times the time. So here's our first example. Mikey has $800 to deposit into a brand new bank account. His current bank offers a savings plan with an APR of 1%, compounded monthly. How much will Mikey make after 2 years, and how much will he make after 10.5 years? So 2 problems in there, and one we're just changing the time basically, but let's identify everything. My principal amount that we're going to invest is $800, okay, at a rate of, now 1%, but remember we said our rate has to be a decimal, so we're going to move that decimal 2 places to the left, so we're going to call that 0.01. Not really a great percentage rate, but it is what it is. And here's that big key, we're compounded monthly. So I'm going to make a note, that's my N we said, compounded monthly, and monthly jumps in my head as 12 months in 1 whole year. And then the time, we have 2 different times. We're going to start at t equals 2, and then we'll do another one at t equals 10.5. So grab those calculators. And of course, we want to get this written out first. So I'm going to say the future amount, the amount I'm going to have, is equal to my principal. So I'm just following that formula from above up here. Whoa, baby. This guy that's up here. So 800, and it's 1 plus, my rate is a decimal, so 0.01, compounded 12 times, raised to the 12 times, we said 2. Okay, now if you can do any math in your head, I would go ahead and do so. So I'm going to say that's 800, 1 plus 0.01 over 12 raised to the 24th. Now notice, because my t's already on this side, we're just typing this whole mess in the calculator. So just carefully punch that in your calculator. Pause it, see what you get. Here's a snapshot of my screen. Notice I'm using that fraction tool. Okay, we want to make sure we use that. And I've got $816 and change, 15 cents. Now, just a quick note, if you have the old calculator, the TI-83, you're going to need to wrap this quantity in parentheses because you don't have that fraction tool. So you're just going to have a lot of parentheses. The other thing you're going to want to do is parentheses around your exponent as well. So again, be really careful on that 83. All right, now they want us to approximate the same, estimate the same value here with a year of 10.5. So the only thing that's going to change, so I'm still going to have my initial $800, 1 plus my 0.01 over 12, raised to the number of times compounded times the 10.5. Okay, now again, be very careful how you type that in. You can type it in just the way it is. Use the fraction tool. Again, on that old calculator, wrap that whole parenthesis in or the whole exponent in parentheses. So again, you can see exactly how I typed it in on my calculator and what I got here. I've got $888.53. We'll round to the nearest cent there, versus my $816.15. All right, Mikey is now given the option of investing his money at 2.976% interest per year, compounded monthly, or he can deposit the $800 in the original account, earning 3% compounded yearly. So basically the question is, would it be smarter for Mikey to take a smaller interest rate but get compounded monthly versus a slightly larger interest rate but only compounded yearly? What do you think is a better deal? Now remember, compounded tells you how often they're going to apply the interest. So they're going to apply interest every month, or they're going to apply the interest once a year. However, this one makes slightly a little more interest. So which one's the better deal? So let's identify everything first. The principal amount that Mikey's going to invest is that $800. My first rate, I have to move that decimal 2 places, so 0.02976. And if it's compounded monthly, that means my n value is equal to 12. All right, so question 1. How much would Mikey have in the account if it's compounded monthly for the 2 years? So my time is going to be 2. All right, so my future amount is equal to the 800, 1 plus the rate, so 0.02976, over my compounding 12, raised to my compounding 12 times my time of 2 years. Okay, now the only catch here, guys, if you have the old 83 calculator and you don't have that fraction tool, which is amazing, you're going to have to wrap this in its own set of parentheses and the exponent in its own set of parentheses. Okay, so that's why it's important to practice with your own calculator. That old calculator, this fraction needs parentheses, and so does this whole exponent. So grab your calculator, carefully type that in, and let's compare. I ended up with $848.99999, so I'm going to say $849. Now, let's compare how much would Mikey have if he did 3% but only compounded yearly. So what's going to change? Well, obviously my rate is now going to be 0.2 places to the left, so 0.03. Compounded yearly, so my n is going to be 1. So I'm going to say my future amount is equal to the 800 times 1 plus 0.03 divided by 1 raised to the 1 times the 2 years. This time I end up with $848.72. So believe it or not, there's not a huge difference after 2 years. However, I still think it would be smarter to go with a smaller interest rate compounded more often. Okay, but again, not a huge difference. So before we talk about this, I just want to be clear, you don't need to copy this down, but you need to listen carefully. Compound interest is a way of life in our society. Understanding how it works and how it can be used effectively to grow your investments is a critical lesson. Investing early can accumulate compound interest over the long term is an excellent way for you to make your money work. Conversely, when you borrow money, try to limit the length of the borrowing term and pay as little interest overall as possible. So again, here's just a quick table showing you what $5,000 can do. So let's say you take your $5,000 and I just annually compound it. After 1 year, I'd make $400, after 5 years, after 10 years. If I compounded it semi-annually, take a look at this, versus monthly. Okay, after 1 year, it's only $15. However, after 10 years, look how much it's grown. And again, daily. So it's really important that you understand what your money's doing. Where are you putting your money? Is it in a bank account? Is it in a Roth IRA? It's not too early to invest and do something with that money, whether you can put in $50 a week or $5 a week. So like I just mentioned, interest doesn't always work in your favor. Most of the time, when you take out a loan, you have to pay the interest back. So here's an example. Calculate how much a 5-year loan of $20,000 with an annual interest rate of 5% compounded semi-annually will cost you. So I'm going to start with my formula. Notice I see compounded right away. So I know my future amount equals my principal times 1 plus the rate over the compounding to the compounding times time. Okay, so my principal amount is $20,000. My rate is going to be obviously 0.05. Compounded semi-annually, hopefully semi gave that away. My N is going to be 2. My time is obviously 5 years. So let's go get that future amount. So let's go 20,000, 1 plus 0.05 over 2 raised to the 2 times 5, or 10. Carefully type that in and see what you get. I end up with 25601.69. Now you notice that's my future amount. Now I already paid that $20,000 was my original, or my principal amount, so the amount that I'm paying in interest is 5601.69. Okay, so that is the interest I have to pay on top of the $20,000 that I have to take out. All right, now we're going to get into the heavy-duty math here. What interest rate was paid on a 5-year loan with a principal amount of $10,000, a cost to borrow of $34.39, and a semi-annual compounding period? So here's what I figured out. My principal is $10,000. I think they give that to me right here. My semi-annual, so N equals 2. Compounding period, 5-year loan, so my time is 5. Now how about the future amount? Clearly I don't know the rate, that's the question. But I should be able to figure out the future amount. The principal was $10,000, and it cost me $34.39 to borrow, so the future amount is $13,439. Right? The loan was $10,000 plus the interest amount, and that's the future amount. So now we're going to solve this a little differently here. So we've got $13,439 equals the principal, $10,000, 1 plus the rate over the compounding, and then the compounding times the time. Now, believe it or not, we did solve equations like this maybe last week or the week before. We're going to have to clean this up and be extremely careful. Okay, I'm going to clean up the best I can here. So I really can't do anything inside those parentheses except rewrite. I can say this is raised to the 10th. Okay, now I can't stress enough. We did this last week. You'll remember we boxed the exponent is only sitting on this term. So we have to isolate that first. So the first thing I want to do is divide the 10,000 over. I know divide because that says times. So divide that 10,000 over, divide 10,000 over. Grab your calculator. I'm not doing all the work here myself. Okay, I get a decimal of 1.349. I'm sorry, 3439, and I'm going to store that into alpha A. Okay, so now I have A equals 1 plus r over 2 to the 10th. If I want to get rid of the 10th power, I have to take the 10th root of both sides. Just like if I wanted to get rid of a square, I would take the square root. Again, we did this in the calculator last week. You start by hitting that 10 first. We're not going to repeat this in class. We've done it twice now. Grab your calculator, do it with me. Grab that 10. Hit the math button. Make a note in your notebook if you need to. Arrow down to the any root, which I believe is choice 5, and use alpha A, that 1.3439 number. I get another hideous decimal of 1.02999, etc. I'm going to store that into alpha B. So now I have B equals 1 plus the rate over 2. Make sure you're storing. You're not allowed to round in the middle of a problem. So my goal is to get R by itself. So now I'm going to subtract 1. So I'm going to do my alpha B minus 1. And I get a 0.029 number. I'm going to store that back into alpha A equals R over 2. If I want to get that 2 by itself, I'm basically just going to multiply. I can think of it as cross-multiplying, put that over 1, and say 2 times A equals R. So I'm going to take that A value in my calculator, multiply by 2, and I'm going to get an R value of 0.0599974,893. Now, the question said, what rate is that? So remember, you got to move that decimal back 2 places to get the percentage rate. So it's a 5.999 percentage rate, which we can probably just say is a 6%. Okay, so again, if I went too fast for you, go back, pause it, rewind it, and play it again. Now, what we're going to do is we're going to solve this equation a second way. Okay, so we are now going to solve graphically. What that means is in hit your y equals, and in y1, we need to put the left side of the equation, so 13,439. In y2, we need to put the right side of the equation. 10,001 plus, we're going to use x over 2 raised to the 10th power. Okay, we're going to start on zoom 6. That's our standard 10 by 10 window. Hopefully you don't see anything. And it should make sense that you don't see anything because you just said the y value has a height of 13,000. So what does that mean? We need to go to our window and we need to change our y max. That's the first thing I'm going to change because I won't see the graph till I'm at 13,000. So of course you're not going to see it in a 10 by 10. So pick something bigger. So I'm going to say maybe 15,000. So go to your window. I'm only changing to start my y max and then just hit graph. So I took a snapshot of what mine looks like. So just to remind you, this part is not an option. We do have to be able to solve these both algebraically by hand and graphically. So now my goal, of course, is if I graph two things, is to find where they intersect. Clearly you can see that this is the straight line, so that's the 13,000 number, and then this is the other polynomial function. Now notice it starts here, it doesn't stop in thin air, it just gets closer, it's just hard to see, it's on that axis. So it looks like it intersects twice, once here and once here. Now clearly this is a negative number. Okay, I do not want a negative rate. I need to find this intersection point. So it's been a while since we've done this, but I'm going to walk you through it again. Jot notes down for yourself. You're going to hit second trace. Okay, trace is on the top row, second trace. You're going to choose intersect. It's number 5 on my calculator. I'm going to assume it's 5 on yours as well. In the top right corner here, it should say first curve. Press enter. It should then say second curve. Press enter. It'll say take a guess. Press enter again. If it found this point for you, you need to do it again. If it found this point, you're in good shape. If it did find this point, guys, when you do your second enter, you need to arrow over closer to this guy over here. Okay, so I got a intersection point of, believe it or not, the R value of 0.059999749, which is exactly what it should be because that's what we got algebraically. So the rate, again, is 5.999% or 6%. But both of these ways will get us to the same result. So let's tackle another one. We're going to solve this again both graphically and algebraically. How long will it take for $3,500 to become $5,800 if it's invested at 8% and is compounded monthly? All right, you got the algebraic part, get it set up. Pause it, don't cheat yourself, and I'll get mine set up. All right, quick check. The only thing I didn't know was the time, so it should look exactly like this. Again, I'll walk you through the algebraic part, but we did do this last week. Box the exponent is only sitting on this term. Box it in. Get rid of that 3,500. I divide that 3,500 over, I get a hideous decimal. It's like 1.657, blah, 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 blah. I'm going to store that into alpha A. 1 plus 0.08 over 12 to the 12t. Okay, this time I'm going to add inside here. So I'm going to grab my calculator and do 1 plus that fraction, 0.08 over 12. And I get another repeating decimal. I'm going to store this into alpha B. It was 1.0066666666. So I'm going to say B to the 12t. Now, this is called an exponential equation because the exponent is a variable. The only way to solve this is by taking the log of both sides. So I'm going to log this side, and I get log of A. And I'm going to log this side, but remember, the third law product says the exponent comes down in front. So it's 12t times the log of B. Now my goal is to get that t by itself, so I'm going to divide over the log of b. Make sure you stored things into a and b. And I get some 76.0165, etc. number equals 12t. And I'm just going to take that number and divide by 12. So I get an answer of 6.334 years. And did it say round? It did not. So it's going to take approximately 6.3 years. Now again, we're going to solve the same problem, but graphically. So I'm going to go back to my equation. You're going to put this side in y1, and you're going to type this side carefully in y2. Okay, just to be clear, there's no t on your calculator, you're using x. Once you've got that typed in, you are always starting on zoom 6. That gets you your standard 10 by 10 window. Now again, you probably shouldn't see anything because you said the y value should be 5,800. So now go to that window, and you're not going to see the y max until you're bigger than 5,800. So I'm going to go with like 8,000, and I'm only going to change my y max. So here's a nice picture of what I have. Again, this is my 10 by 10. I just changed my y max so I could be bigger than that 5,600. And because I can see the intersection, I don't need to change the x's at all. I need to go get that point. So again, you're going to hit second trace, intersect, basically enter, 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 and hopefully you get the same number that we got here. I got t equals 6.334, so I know I did it correctly. So again, it should take 6.33 years. So if it said to the nearest year, notice you'd have to say 7 because it doesn't happen at the 6th year. It happens sometime during the 6th year. So just be real careful on the wording of that question. If 500 is invested and compounded continuously, there's my keyword, at a rate of 2.345%, in how many years will it reach 37,500? So I'm going to start with my keyword of my continuously. So f of t, my future amount equals pert, p-e to the rt for continuous. Let's see, my future amount is 37,500. My principal is 500. Remember, e is that nice Euler's number. My exponent is going to be 0.02345 when I move that decimal, times t. All right, so again, box this in. This exponent is only, and I stress only, on the number e. So your first move has to be to divide over that 500. Again, these are questions we solved last week. Hopefully this is not new to you. Pause it, grab that calculator. So I'm going 37500 divided by 500. I get a nice 75. So you can store it or not since it's a nice number. Equals e to the point 0.02345 t. Okay, now I want you to think back for a moment. When we talked about e's, they went with natural logs. So instead of taking the common log, log of both sides, I'm going to use the natural log of both sides. And I have to do that because this is exponential. So I'm going to say the ln of this side of 75 is equal to the ln of e, and that third log property takes that exponent and moves it down in front. 0.02345 t times the ln of e. Next step, I'm going to get this t by itself, so I'm going to divide both sides by the ln of e. So I'm going to do that ln of 75 divided by the ln of e. Now I get a nice hideous number, 4.317, blah, blah, blah. I'm going to store that into alpha A. Equals 0.02345t. And then to get that t by itself, again, we'll divide by 0.2302345. And I get t equals 184.1146. All right, so we're going to solve this one graphically as well, just to verify that we should get that same number. And again, sometimes they might just say graphic only and not algebraic, so we have to make sure we can do both. The left side here is going in y1, and this whole right side in y2. And I'm going to carefully start on a zoom 6. Okay, that gets me my standard 10 by 10 window. Now I'll realize I'm not going to see anything. That one number was 37,500, so I'm going to make my y max like a 40,000. All right, so you can see my 40,000 line, and I watched a graph, and I saw it kind of creep up, but it's so hard to see. And, you know, from algebraically, we know it didn't intersect to 100 something, so I'm now going to change my x max, because I know this is slowly growing. It's exponential. Remember, exponential grows, and then it'll shoot up really fast eventually. So I need to make my x max much bigger. I'm going to shoot my x max out to 200. You should do the same. So now that I've expanded that window out, I can clearly see that intersection. Now I'm going to go second trace, intersection, enter, 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 and it should grab that intersection, and I end up with 184 again, 0.114, which is correct because that's what we got when we solved it algebraically. So in summary, our compound frequency is our future amount equals our principal times 1 plus the rate over the number of times it's compounded, to compounding times the time, and our continuously is our future amount equals our PERT, P-E to the RT. So again, yes, we're going to remember those, so get them stored in your memory bank, and we'll get a lot of practice tomorrow. Have a good night.